Okay, welcome back to another video. So in this video, we will start building out our backend. In today's video, we are going to focus on the foundational piece. So we'll be building out the backend using Axum or using the Axum framework. We'll build out all the foundational pieces such as connectivity to the database, session management, but not really be concerned with too many of the final endpoints we'll be using. And then in the following videos, we'll build up authentication, we'll build up secure storage of your wallet with encryption and all of that. But before we get to that point, we need to do the foundational piece, which we're doing here. And so if you remember yesterday, or in the last video, we have built out the front end. We have set up an Anvil node such that we can interact with it. We successfully managed to create a transaction inside of our wallet. And with that, we managed to send from one wallet to another. If you haven't checked out the previous videos, do that. So just to give you a quick recap, we have the setup wallet screen. You encrypt your wallet with a password and you press setup wallet. And what we had built up is the entire wallet where you see your wallet balance. You have the possibility of transferring to other wallets and all of that functionality is working. What we haven't built yet is the transaction history. We haven't built out the receive here. And we could probably do with a little bit of polish on the wallet. But for now, this is good enough that it's actually a functional wallet, even though that is incomplete. Getting back to our code base, the very first thing we want to do is setting up the backend. And so the backend lives in app/backend, and we need to just get the very foundation up running here. So in the the crate that we created some time ago, you'll see that there is just a hello world file or a hello world implementation. And so this hello world implementation we need to change into a functioning Axum server. And so for that, we're going to create another terminal here. So we now have the front end running up here. We have the blockchain running here. And we'll also need some place where the database can be running. Actually, I do not recall where I put the project. Let's just... Okay. Setting the backend back up, or the front end back up, and inside of the backend, we're just going to do a cargo run to check that it works. Then, check that it's running as it should. Then on this side over here, we'll just touch the Docker Compose. So over here we'll be running the database. We'll do that inside of Docker Compose to make it easy to run. Okay, and so we see here our Hello World application is up and running. But in order for us to build out our backend, we'll need a few dependencies. So we're going to do cargo add. We're going to add Axum, Axum server, Tokyo, tower, HTTP, tower, Axum extra. We want a logging framework as well. We want to be able to store secrets in a .env file. We need the environment logger, chrono, cert JSON. just start with those ones. Actually, let's also add request. Start with these ones. This should be enough that we can get going. Okay, and we have one more we want to add. We want to add the create time. Okay. So with that, we will go to our code editor. And we will delete what is here now. And so the very first thing we want to do is simply just create a very, very basic server. So this server, we want to just add a health endpoint, but we can check that the server is running. And so the first handler we are writing is as simple as it gets. It's a async function that we call health check, which returns JSON, and so we use cert JSON value. And inside of this one, we're just going to do JSON, and then we use the JSON macro, so we don't need to have a struct defined for it, and we're just going to do status OK. Then unlike asynchronous program, we are going to make an asynchronous program. We're doing this by using the macro Tokyo ::main before we define our async function main, which will return a result that is either unit or it has some error. And so what this will do under the hood is it will set up a async runtime and it will invoke our main function, such that we don't need to deal with that ourselves. Okay, then we set up the initial logging. So what we do here is we check whether we have set the log variable. If we haven't, we will default to trace for now. Probably for any production system, we would want this to be info and then trace optional. But since we're just developing here, let's keep it to trace. And the way we log things is simply by using the macros error, info, debug. The actual app itself is set up by creating a new router. And then with that router, we're going to add our health checkpoint. And this is a get function. Well, it's a get view to the health check. And then we're also going to add a layer that allows us to do that sets course to be very permissive. Finally, we need to set up the server, and to that end, we're going to give it an address. So in a more advanced version of this, we could make this a command line argument. We're not doing that here. We are simply just going to set it up. So we ask it here to listen to the address, unwrap that, and then we're going to serve the application on this particular listener, which is done with Axum serve. And then finally, our main function should return OK. And this is about as simple as it gets. Like, there's not much to it. Next, we are going to test whether this actually works. Okay, we have our first error. We probably need to add a feature here. So typically what happens is that if you read a tutorial on something in Rust, so this is very different from what you would have in TypeScript or JavaScript. But typically when you are using a library in Rust and you're looking at a tutorial or example where things are explained to be done in one way, and then you get an error like this where it doesn't exist, what typically happens is that you have some feature in the crate that you need to enable. And I think this is what's going on here. So let's just have a look. Let's have a look here. And see, so we need to find the and I guess that this feature might be called course. If it's not, we'll have to look in the documentation, but I'm almost certain. I'll see what happens if we do that. Oh, and we probably also want to talk you to be full. Let's fix that as well. Cool, so we have our backend up running. It's not doing much at this point, but let's just test it out. So we served on port 8000, and we added the endpoint API v1 plus health checker. Or not. What was actually the endpoint we ended up adding? Oh, just /health. So we added the endpoint v1/health. Okay, something isn't working for us here, so I wonder what the issue is. Let's see. Oh, 800, right. Let's just fix that. Okay. So we start the server again. And there you go. We have our backend server up running. A very simple one, but nonetheless, the first version of our API just with a health checker. Cool. Then we're going to build out some of the foundational stuff that we want to do here. And so one of the things we want to do is that in the long run, we want to set up password authentication for our wallet. So you log into the backend with one password. This will give you access to your assets in the database. And then you get your wallet and you can decrypt that one with a wallet password. In order to set up the authentication eventually, we'll need to have support for cross-domain cookies, which means that, it might not even be cross-domain, it might just be on the same domain, but regardless, we need to set it up such that we can store cookies and receive those ones for our session. And so in order to do that, we are going to create a section here where we start out by setting up what is the domain that we are using. So we're going to unwrap that, or else we're going to assume that it's localhost we're working on. let's split that into parts. So we want to figure out if there are any subdomains in what we are doing here. And so the reason for this is if you're going to serve your application across multiple domains, it is helpful to do the splitting of the domain such that your cookies work across these subdomains. And so we will say what we expect back here is a vector of referenced strings. So in the case that there are no parts in the domain, we're just going to make the domain group the domain. And otherwise, we are going to take the domain. We're adding a dot here, which indicates to the browser that and the server that the cookies live across multiple subdomains. So I hope this makes sense. Okay, so that was our domain. Then we'll do something with this domain a little bit further on, but before we get to that point, we need to get our database set up. And so for that, we've created this YAML file for Docker Compose. And we'll just populate that with a very standard setup where we have Postgres. We're using the image Postgres 16. We will call this walletDB, and we are having some wallet user and wallet password and walletDB. And we're serving that on port 5432. Great. We will also create a .env file for our application. Oh, not folder, new file, .env. And so inside of this one, we are going to add a few different things. We're going to add what is the output mode in terms of logging. We'll set that to debug. We'll have a server secret, so this one we'll be using for when we're managing the sessions and all of this. And then we'll have the database URL. Then with this information, we want to be able to connect to the database. So we will create the connect to database.rs. And so what this function file will do is it will be a very, very contained piece that just have a single function, which is an async function connect to database. And so this will return either a database pool or an error. Okay. We declare this as a module inside of the main. Okay, so the key idea here is that when we start everything up, so eventually we're going to move the whole thing into Docker Compose, or at least we would in a slightly more advanced setup. And so there can be a delay in when things are starting up, right? So you start up your backend, you start up your database, you start up your front end all at once, and maybe the backend is starting up quicker than your database, in which case you need to wait for it. There can also be other connectivity issues, and so we need to set up the connection to the database and then make sure that we are trying again if it fails. And so we will do this with an exponential backoff and making sure that we are making sure that we retry a number of times. And let's just, if this fails, we will return an error saying that we are missing that. We're also going to add a max timeout. And finally, we will have a back off counter, which will be mutable. Okay, and so we measure the timeout in terms of iterations we are doing in this loop, right? And so just every time we are doing a single loop, we'll do Tokyo time, sleep, duration from seconds, back off time dot await, right? And so this will make sure that we wait the number of seconds that's in our timeout. So first we'll wait 1 second, and then in the second iteration, if we fail again, we want to wait 2 seconds, 4 seconds, and so on and so forth until we reach our maximum timeout, which might be, I don't know, 100 seconds or even 10 minutes. Okay. Right, something tells me we haven't added SQLX. Let's just do that right away. And we have a number of features that I like to have there. So we'll just update SQLX here. Do version. We'll disable the default features. We'll use Rust TLS instead of the normal TLS. We'll add support for Postgres. We'll use the Tokyo runtime, support for Chrono, and again, we are sticking with Rust TLS. So one of the reasons why I like sticking with Rust TLS is because this allows you to cross-compile. This is a very advanced topic that's not for this video, but just as some background information, one of the things you can do is I can cross-compile this on a Mac OS setup from ARM directly into an x86 such that when I deploy to my Kubernetes cluster, it still works. Whereas if you're using the native TLS, you will be less successful with that approach. Well, you'll fail miserably, to be honest. So that's why you probably don't want to do that. Okay, let's just get that there. And that should make that we start getting some type hints as well. Let's see. Right, and we need a comma here. Let's see. Or not. Right. Okay, that seems to be formatted correctly now. We still don't expect things to compile, but now we see, or we should see, type hints showing up if we've done this right. Okay, cool. This is great. We want to return an error at the end of this. Right, so in the event that we exit the loop, we are always returning an error, and that should fix this error, right? And then the last thing we need to do is simply creating our pool. And as always, this is done with a match statement that will tell us whether there was any errors while we tried to do this. Oh wait, that one does not belong there, it belongs here. And we have an error case as well. And in the case of error, we just want to put out an error saying database connection failed. And otherwise, we want to give info successfully connected to the database. And then we return OK pool. Right, and we need to remember to await for this to work. But other than that, we should be good to go. Okay, let's go back to our main file. And then just inside that one, we are going to import our new connect to database. See, that was what we called it, wasn't it? Yes, it was. And with that, we will create our database connection here. And actually, this is a match statement because it might fail, right? So connect to database dot await OCO-DB, and if it is okay, then we're setting the variable to DB, and otherwise we're simply going to panic. This is supposed to never happen, but if it does, we want to terminate everything right away in the most catastrophic way we can think of. Okay, let's set up our database. database is up running. Let's start our backend again. And we successfully connected to the database. Yay! So we can now start implementing something that actually loads and stores things to the database, such as sessions, which is one thing we want to do. As well as we are going to create a basic user table. Let's just do that for the fun of it. But in any case, we are connected to the database now. And so before going any further, let's start setting up some of the basic error handling. So inside our library here, we will have so the app config is basically shared between the backend and the front end, and contains a lot of the shared functionality we are using. And one of the things we want to have is we want to have the ability to discriminate on whether we are compiling this for the backend or the front end. So in order to do that, we're going to add features here. And so what features are basically ways to say to Rust, when you're using the create here, you need to include this extra code, and when you're using it here, don't include that. And so that's what features allows us to do. And so for the backend compilation, we want to add the dependency Axum, which allows us to do such things as mapping error codes and whatnot. Then we will add a bunch of extra dependencies here, and with that we will need to move our dependencies from here to the actual workspace. And so we're doing that now. So these are extra dependencies that we share across the workspace, and we can now update this one up here and just make it all into workspace variables. Right, and or rather, we are making it into workspace dependencies rather than local create dependencies. So we have all of these ones here, and we're still getting some errors from the Rust analyzer. Let's see what it's complaining about. Right, UUID, we haven't added that yet. So still complaints. Okay, but now it at least builds. That is great. UUID, I don't know whether we will need that just yet. We might or might not. Let's just add it here. Cargo add UUID. Right, and so we're just moving that one to the workspace. If you look up how UUID actually works, you'll realize that UUID is one big mess. It basically has 8 different versions, and what I've learned is that I nearly always want to use version 4 because that seems to be the most reliable version of them. I'll not bore you with how the different versions are working, but there are some interesting videos and blog posts on the internet explaining all of that, which I think is quite interesting. Why we have all these standards. Okay, let's see. Great. So we are ready to extend this. So we have the app routes that are shared across the applications. But then we also want to add things that we are using. So we'll use the HTTP status code if we're using the backend. Otherwise, we're going to manually write these numbers out. The same for into response. So what we are going to do in this crate is we're going to create a error response. We're going to create an error response struct that we can use in the backend to just return an error response, and we can use it on the front end to pass the error response. And this, keeping it in this shared repo that's shared across all the crates, that's shared across all of the other things, makes that we can have a standardized way of doing this. We're going to make some of the code conditional, which means that in one version, it will be implemented as one thing, and in another version, it will be implemented as another thing. So status code, if we're doing a backend implementation, we are going to add the status code here. If we're doing a front-end implementation, we will do it as a I32, or rather, if it's not a backend implementation. And then for the backend, we're going to make a into response, which means that if we've created an error response, we have a way to convert that into a Axum response. And this is super useful because this means that we can now just return error response as an error anywhere, and it will be super easy to convert it into something that Axum understands. Okay. Then let's also just implement some helper functions. We're going to add implement the error response, and then we're going to do the different kinds of error responses that we would want to have, and just standardize that slightly across the whole thing. And I will not bore you with implementing all of this here, so I'm just going to copy that across. This is very, very standard, right? So basically what we're doing is we're saying there is a member function called unauthorized. It's a static member function. That one will return a version of self that says fail, you're not logged in, and then the corresponding status code, right? And we need to implement this both for the front end and the back end. And so we're just adding all of that here. And this makes a standard way for us to deal with all the error messages. So now we have the backend version, we have the corresponding front end version. So we don't have Axum available on the front end. So for that reason, we need to map the number into the right one. And we just do this for all the different ones. That means that when we're in the rest of the code base, we don't need to worry too much about the status code, but more what is the error kind we're dealing with here. Great. And this is a public struct, so this should all be fine. Cool. Right. The last thing we actually need to do in this bit here is we've created the database, but we want to make the database available across the different views that we're having, right? So right now we're just creating the database, but we actually don't do anything with it. And so if I were to use the database in the health checker, for instance, I can't do that at the moment. In order to fix that, we will add an extension layer. And so there are a few different ways we can do this in with Axum. So we can either do extension, or I think the other one is state. There are subtle differences in how they work. So one has compile time guarantees and the other one only runtime guarantees. So the extension layer for database only has runtime guarantees, but it has the benefit that it's very easy to get nearly anywhere in the stack of the Axum application. So when we are in a piece of the middleware and we want to check is the user logged in, we can get access to the database via the extension. And it's usually very easy to detect whether we have done this, so we don't need compile time guarantees. Like usually if you don't have the extension, your component will break down immediately with a message that this is this isn't working. So we're going to add that here, and now the database should be available in all our different views. Oh, and I see we broke the front end. Let's just see why we broke the front end here. Right. So all the different changes we did has made that how the random number generator is coming in is being forced into being a different one than the one we need. So a specific source, right? So that's for UUID. We have that. Okay, so this is a small aside. We need to fix the front end, or rather, let's see which. Okay. Well, one thing we do want here is we also want serialization. And then let's see. We don't manually import rand core. Let's see if adding this dependency is enough to fix the issue, or we need to do something more. Previous. Okay. So this is one of the slightly tricky things when you're developing both front-end and back-end in Rust. You might have that there are conflicting requirements. So on the back-end, we have one kind of random number generator, and on the front-end, we'll need a different kind, simply because the source of the randomness differs. And I wonder if UUID has a JS feature. Let's look that up. It does have a JS feature. There we go. See what happens if we just add that in here. This may or may not solve the issue, and it might be that we conditionally will have to turn this feature on. Okay, it's building again, great. So it was as simple as that, just adding the JS feature to adding the JS feature to the UUID crate made that everything is compiling again. And same on the back end. Great. With that, we are ready to move on to the next step, which is we're going to create a basic user model. And so what we're going to do is similar to how we've created a wallet subdirectory, we're going to create a auth subdirectory. And then inside of auth, we're going to do cargo new auth API. And this will contain our API and database types. And it's going to be a library. And while we are at it, let's just add the app as well and the screens. So the idea here is we are going to make two separate crates for authentication. We're going to make the core authentication framework, which will just be concerned with storing the users, storing the basic information around the sessions and stuff like that. And then we'll create another one that's called auth password. So the idea is that the core authentication is different from how you're actually authenticating the user. So if we at some point want to remove auth password and instead adding Google login or something like that, or one-time passwords, we can quite easily do that by just taking out that one component. Okay, let's start by setting up some dependencies here. And just like the config crate, we're going to have some features here. And so the idea with all the API crates, so auth API and wallet API, is that they will be shared between frontend and backend, making sure that that interface is always the same on both sides. But we do want to have some specific differences between the two, which is why we add features for the backend and sometimes features for the front end. So we want to have support for SQLX, Axum, and a whole bunch of other things when we are doing this for the backend. Then we want to add serialization support for time, support for UUIDs, optionally support for SQLX, Axum, and asynchronous behavior and so on. Actually, we don't need the async one. That one is, and we neither need anyhow, but we need these other ones. Okay, going back to the main implementation of the auth API. We are now going to implement the most basic things we can come up with. So the first, we're going to implement the basic stuff we need for the user. So we're going to import these things. So we're going to import the date and let's just take that one again. We're importing time. We're importing the things we need for serialization, and we're importing the things we need for ID. And we want to create a user struct that allows us to store a user object into the database. We also want to be able to serialize it so we can return it, and we want to be able to clone it and compare it, right? So the basic fields we'll have in our user struct is just the ID, the name. The name we will make optional because this allows us to make it so you can sign up just with an email without having to give a name. If we want to enforce name, we'll do that in the handler itself. But to keep this generic, we're going to make it optional. And we'll have a role. It's useful to be able to create roles where we, for instance, could have an admin user that will be able to do more things in the system than the rest of the users. Okay, then in order for us to interact with or store this in a database, we are going to say, well, if if we are working with the crate where the feature backend is enabled, we want to derive SQLX from row. Now, from row allows us to extract the data from the database and put it into an instance of the struct or multiple instances if we're getting a vector. And then together with that, we want to have the usual stuff. We want to be able to debug, partial, compare. We want to be able to clone, and we want to be able to serialize and deserialize. This is our core object that will be used for the database and for the and for the API. Then we want another object as well, and this is the logout object or the logout response. So this is going to be an API response. And this one we will just serialize, deserialize, and debug. And so this is one of the responsibilities of the core auth crate. It can log you out, and it will store the things around the user, and it will provide all the guards and all of these things we need to make sure that you can only access things when you're logged in. But other than that, it will not do much more. Next, let's create the migrations. So inside of Backend, we're going to create a folder called migrations. And we're going to do SQLX. Let's see, I think it's add, migrate add. What's migrate create? I can't recall. Add. And this one we will call user table. Let's see. Oh, wait. Yeah, it created it. We need to have a user table that matches what we have now struct. And so we're just adding that. We make sure we import the UUID support. And other than that, we are making sure we have all of the things we had in our API here. We have the UUID, we have the name, the username, and all of that. We just carry across here and define inside of this. Then, in order for this to actually work, we will need to update the main file to run the migrations. And let me just have a moment to think here, because it appears that I actually don't cover this in the book, and that this is something that I've come up with after writing the book and something that I use in the projects. Okay, so this is going to be a video special. This is not in the book itself. Let's just implement it anyway, because I actually think it is super useful to have. So the idea here is that every time we start up the backend, we want to apply the migrations. And so the way we will do this is we'll import the SQLX migrator. And then after we've connected to the database, we are going to do m equals match migrator. We're making a new migrator and path new / migrations. This means that you must have your migrations together with your backend. Now, one thing I would say about this is it's super useful for developing. It might be something where you need to be slightly more careful when you're doing a production version of this, because if you have multiple backends starting up at the same time, it may cause you some trouble. But for now, let's just do it this way. We could also just use the SQLX migration, but we're going to list out what are the available migrations we're having, and then we're going to run this. And so we do migration run, we're doing that on the database, and then we have applied the migrations. Let's test this out. In the slightly longer run, we would probably separate this out into its own executable, or we would use the SQLX migrate functionality. But for now, let's just try to see cargo run. What does it complain about here? Oh, right, we forgot to update. So we don't have these two here, so they can go. Cool, let's see. So we've applied the migrations. Did we find any available migrations? Yes, we did. We found a user table migration, and so that one is applied now. And if we run it again, it should not apply it again. Oh, it does seem to apply it again or not. Let's just see what's going on here. Relation already exists. Right, summary. So we should see something that says that this I'm kind of curious here, so did we actually apply that one? It shouldn't have been applied a second time. I don't think it... Right. Let's just try to do this. Wonder if that will... Oh, wait, now we stopped the database. Oh, so that is a, I see, okay. Well, let's see if AI can help us a bit here. Let's just see how that works out for us. I thought that one returned unit. It seemed like that. So I don't think this is going to work, or maybe I'm missing something here. Yeah, exactly. So this is unit, so you can't do that. That doesn't work. That was the whole reason why we had to ask AI in the first place. Now it's just being silly. Like, the text clearly explains that this ought not to be possible. Right, and we tried that just before. Let's just see. Actually, let's just try to do something here. Migration dot. Let's try to do this instead. Okay, one of those times where we probably need a bit of documentation help. So So what does this field mean? No TX. Right, so clearly it has the description, the version. Okay. Okay, this is a bit of improvisation that failed. Well, partially failed, right? So we have figured out, or we have gotten it to apply the migrations during startup, but somehow we fail at getting it to provide the information about whether it's actually reapplying it, which is slightly annoying because it seems like it's reapplying it, which it really ought to not do. It doesn't matter for the SQLX query we have done, but nonetheless, I would really have expected it to not do that, right? So you see here, the SQLX migrations already exist, so that one is not reapplying. But then this one, right, summary equals, right, okay, so we're selecting from, oh, I see. So it might, I read that as that it actually does apply it again. It shouldn't be doing that. Okay, we're just going to try something else here. See, does this create the directory as we would expect it to? Yes, postgres.db. Right, now we can easily delete the data when something is happening. Let's just run this one. Okay, this does seem to do more than it otherwise would. Let's just compare the two expressions. Or the two cases. One row returned. And here it returns 0 rows, right? And then right after that, here it execute a create. Okay, that was a very long way to go to see that it's actually doing what it's supposed to. Probably I would want to extend the script to be better at giving that information, but in the name of getting on with things, let's leave that for now. So I think with that, we are in a good place to stop, right? We have created the basic server, we have connected to the database, we have created the initial user table, and we're now ready to go to the next level where we will be setting up all the backend stuff for getting the user information and locking out, making sure that we have authentication guards and all of this. And so these are the things we'll be looking into in the next video. I hope you enjoyed this video. If you did, please subscribe and